Hi everyone, this is Sunita, Assistant Professor in AC Department, Siddhartha Academy of Higher Education, deemed to be University. Uh, Today in class we will see introduction to transistors, types of transistors like unipolar transistor, bipolar junction transistor, transistor operating modes, saturation mode, active mode, cutoff mode, like that, and operation of, we will see the operation of the both NPN transistor and PNP transistor, the transistor configurations, how the transistor configurations will work, common base, common emitter, and a common collector configurations. Now we will see the definition of the transistor. The transistor is an electronic device made of three layers of semiconductor material that can act as an insulator and a conductor. Transistor is nothing but back-to-back connection of the two diodes. Two diodes back-to-back connection. And the transistors are classified into two types. So based on the conduction type of the conduction, the transistors are classified into two types: unipolar transistor and the bipolar transistor. Unipolar means the conduction takes place due to the either electrons or holes. Unipolar, that means the polarity is single polarity. The conduction takes place due to either electrons or holes, which are the majority charge carriers. Suppose the transistor is like if the layer is p type, the majority charge carriers are holes. The conduction takes place due to the holes. The minority charge carriers conduction electrons can be negligible. At the same time, if the material is n type, majority charge carriers are electrons. The conduction takes place due to the electrons in the unipolar. Coming to the bipolar junction transistor, the conduction takes place due to the both electrons and holes. The name itself indicates bipolar, so dual, both. So the conduction takes place due to the both electrons and holes, both the majority charge carriers and the minority charge carriers. See here, this is the uh, fabrication of the transistor. The transistors, again the BJT, bipolar junction transistor, we will see bipolar junction transistor operation, everything here. Bipolar junction transistor again classified into two types: NPN transistor and PNP transistor. See here, N region. The fabrication is like that. Take N type of semiconductor, N type semiconductor, sandwich p-type semiconductor in the middle. Sandwich p-type semiconductor in the middle. So see, this is the one layer, this is the second layer, this is the third layer. N-type, p-type, n-type. So this is the NPN transistor. NPN transistor. If you want PNP transistor, exactly this opposite. Take p-type semiconductor. Take p-type semiconductor. Sandwich n-type semiconductor in middle. Sandwich n-type semiconductor in middle. Then PNP transistor will form. So we can take the three terminals from the three layers. This terminal, take this terminal, and take this terminal, and take this terminal. So this terminal is called the emitter. Emitter. The middle terminal is called the base. This terminal is called the collector. Emitter, base, collector. The transistor is a three terminal, three layered and two junction device. Two junctions. Here we know that when P and N type is combined P type and N type material combined, there is a formation of the PN junction. Here the P type material, N type material, there is a formation of the junction. At the same time, here p-type material and n-type material formation of the junction, p-n junction. Two junctions, three terminal, three layers, two junction device. This also is called a emitter collector, sorry, base collector junction. Base collector junction, junction between, how this junction is formed between the base and the collector. This junction is called the base emitter junction. Base emitter junction. base collector junction, base emitter junction. uh, Emitter terminal, emitter sends the carriers into the base region and then into the collector region. Base acts as the control region. It allow the sum or none. See here, here the doping concentration is given. The width of the emitter, base, and collector terminals are different. How they differ means, see here. This is the emitter, base, collector for NPN transistor. Emitter region is heavily doped, and its job is to emit the carrier into the base. This emitter region is heavily doped. Base is slightly doped and thin. Base is slightly doped. Doping concentration of base is very less, slightly doped when compared to the emitter, and the width is very thin. So next, collector. The most of the current carriers injected into the base pass on to the collector. The collector region is moderately doped and is the largest of the all three regions. The collector is the moderately doped and the width is more when compared to the emitter and the base. Emitter is heavily doped, base is slightly doped, collector is moderately doped. Base is thin, collector width is largest when compared to the remaining two. This is the NPN transistor. Same like that PNP also. PNP, emitter, base, collector, heavily doped, lightly doped and thin, moderately doped, and the width is large when compared to the remaining two terminals. See here the position of the terminals and the symbol. PNP transistor, NPN transistor, emitter, base, collector. So this is the transistor symbol. The circuit representations, how we saw in diode representation in the circuit. At the same the transistor representation in the circuit. The base is located at middle and more thin from the level of the collector and emitter. See base. How we can differentiate in circuit, this is NPN transistor and PNP transistor. This arrow mark, the current direction arrow indicates this arrow mark. This arrow mark indicates the current direction. By this arrow mark we will differentiate. This is NPN transistor and this is the PNP transistor. See here, the arrow mark is away from the base towards the emitter. The arrow mark from the base to emitter. This is the NPN transistor. This arrow mark indicates the current direction. If the arrow mark towards the base, away from the emitter towards the base, this is the PNP transistor. I already said a transistor is nothing but back-to-back connection of the two diodes. See how the diodes will construct the one transistor. See here, PNP transistor. This is the PNP transistor symbol. A figure represents the PNP transistor. This transistor is a back-to-back connection of two diodes. See here, two PN junction diodes. PN, P-type, N-type, P-type, N-type, back-to-back, P-type, N-type. Though both negative terminals N sides are attached, that will take the base. This is the emitter. This is the collector. PNP. Same like see here NPN transistor, P-type, N-type, P-type, N-type, both P-type attached and take one terminal base. Emitter N-type, base P-type, collector N-type. NPN transistor. Transistor currents. See here, uh, NPN transistor and PNP transistor. So PNP transistor current towards the base, away from the emitter, IE. This is the entering current. So this is the leaving current, IB, IC. So always IE is equal to IB plus IC. How this equation I will explain next slides in the operation of the transistor. NPN transistor, away from the base current direction, IE leaving current, IB entering current and IC entering current. IE is equal to IB plus IC. See here, transistor biasing. How we connect the transistor in the circuit to operate for different applications. Transistor acts as a switch, amplifier, like that. So we know that transistor is a three terminal, three layer and two junction device. So emitter base collector, two junctions are emitter base junction and base collector junction, or collector base junction. Sometimes we will call the input junction and the output junction. So emitter base junction is the input junction, collector base junction is the output junction. To access a amplifier, the transistor is always connected. Input junction is forward bias and output junction is in reverse bias. For any transistor, NPN transistor or PNP transistor, to access an amplifier, the input junction is always connected to the forward bias, output junction is always connected to the reverse bias. Let's see one example. NPN transistor, emitter base collector, NPN. So input junction is forward bias, emitter base junction is forward bias. N-type battery, N-type material battery negative terminal, P-type material battery positive, forward bias. Collector base junction, the output junction is in the reverse bias. Reverse bias, N-type means battery positive, P-type means battery negative. This is the graph. Like PNP transistor, input junction is forward bias, P-type battery positive, N-type battery negative. Output junction is reverse bias, P-type battery negative, N-type battery positive. Transistor operating modes. What are the operating modes of the transistor? Based on the input output junction biasing, the transistor can operate in the three modes. See here, the both junctions are in the forward bias. That means the both input junction, output junction, emitter base junction, collector base junction, both connected in the forward bias. Then transistor is in the saturation region. It acts as application as a switch, on switch. On switch, it allows the charge of the carriers, flow of the charge carriers. On switch. If the both junctions are reverse bias, that means the both input and output junction, emitter base junction, collector base junction are a reverse bias. It acts as a off switch. It restricts the flow of the charge carriers. Off switch in the region, cutoff region. Transistor is under the cutoff region. So already we know that if the input junction is forward bias and output junction is reverse bias, it acts as an amplifier and it is in the active region. Active region. For opposite this, if what will happen if the input junction is reverse bias, output junction is forward bias, it acts as a attenuator. Amplifier means which amplifies the signal strength, which increases the signal strength is called the amplifier. Attenuator means which decreases the signal strength is called the attenuator. Same active mode base emitters forward the same concept repeated here. See here, working of the NPN transistor. Already we know the working of the PN junction diode. What will happen when PN junction diode is in the open circuited? Forward bias circuit, reverse bias circuit. The same transistor is nothing but the connection of the two diodes. The same operation here also takes place here also. See the operation of the NPN transistor. Uh, NPN, emitter base collector. Emitter is heavily doped, base is lightly doped, collector is the moderately doped. See here, for amplifier, the transistor input junction is in the forward bias, output junction is in the reverse bias. Uh, N-type forward means connected to the battery negative, P-type battery positive. Battery positive reverse bias, N-type material battery positive, P-type battery negative. This is the ground. Whenever we connect it like this, we know that this is nothing but a PN diode. PN diode forward bias. PN junction diode forward bias. In forward bias, what will happen? The width of the depletion layer of the PN junction diode reduces, decreases, and then the charge carriers gain sufficient energy by applying VEB. Whenever the applied voltage is greater than the cut-in voltage, the depletion layer barrier potential greater than this, there is a charge carriers flow. There is a flow of the current. That voltage is called the cutting voltage. Like that, whenever we applied VEB greater than the barrier potential, the charge carriers movement takes place. Whole electrons will flow from emitter to base. Electrons will flow from emitter to base. Some of electrons here recombine with the because base is a p type. P-type means majority charge carriers are holes. Some of the electrons recombine in base with the holes constitute a base current. The base current is very less because the base is lightly doped, very thin and lightly doped. The base current is very small in terms of the microamperes. Because of the less doped and very thin, base current is in terms of the microamperes. The remaining electrons which are coming from the emitter, which emitter emits the electrons, some very less recombine in the base. After that they move towards the collector. This current constitute the emitter current, base current, and the collector current IC. So electrons moves from N to P, this side, electrons moves from this side. See here, negative charge, here the negative charge get repelled, both repelled towards the positive charge. The same IE is equal to the amount of electrons emits from the emitter. IE is equal to the amount of the electrons recombine in the base, which constitute the base current, plus the electrons enter into the collector, which constitute the IC, collector current. IE is equal to IB plus IC. IE is equal to IB plus IC. Positive negative electrons move from the N side to P side. Positive negative. IE is equal to IB plus IC. At the same, like saying working of the PNP transistor. So see PNP emitter base collector, heavily doped, lightly doped, when thin, and collector is moderately doped. Input junction is forward bias, output junction is reverse bias. Same operation. A forward bias means the depletion layer with reduces and there is a flow of the charge carriers. The holes moves from emitter to base. The combine here consider less base current in terms of the microamperes. The remaining will move to the collector. So IE is equal to IB plus IC here. The direction is minus of because the whole current here direction. Uh, Transistor configurations. What are the transistor configurations? Transistor has three terminals. In the circuit, we connect in the transistor. One terminal is the input terminal, other terminal is the output terminal. Then, if you connect a transistor in the circuit, the network, the pair of terminals input and pair of terminals output, we need a four terminals. But we have for transistor only three terminals. For that, we'll take one terminal as common to both the input and the output. One terminal common to both input and the output. Suppose the base terminal will take common to both input and output junction. That is called the common base configuration. In common base configuration, input terminal is emitter, output terminal is collector. Input is emitter, output is collector. The base, third terminal base is common to both input and output. That means the pair of terminal input is emitter base. The pair of terminals output are collector and base. Next, if emitter is common to both input and output, input terminal is base. We are collecting output across the collector, and we are making emitter is common to both input and output. That is called the common emitter configuration. Next, common collector. Common collector means input terminal is base. We are collecting output across the emitter. We are making collector terminal is common to both input and the output. See here, this is the current direction, how common base and common emitter, common collectors are connected. So see, NPN, take NPN transistor, base is common, uh, input is emitter and output is collector. Output terminal is collector, input terminal is emitter. So input junction is forward bias. This is NPN, 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 P, terminal positive, negative, N, reverse bias, positive, negative. The current direction, see here, entering current, leaving current, leaving current. So I is equal to IB plus IC. Like that, we will see common emitter and common collector configurations, and in next class we will see the common base input and output characteristics. Thank you.